Okay, so let's just think real quick. We've kind of recap a little bit what we've learned about radians, okay? And what we know is that radians come from the idea of measuring the perimeter or the circumference of a circle. Okay, you saw when we created a circle with unit 1. Now this is called the unit circle, right? It has a radius of unit 1. Okay, so then what happens is when we measure our 2 pi r, if the radius is 1, then we measure the rotation around the circle in 2 pi. It goes around all the way around. It equals 2 pi, which if we think of that before, how many degrees it goes 360 degrees, but the distance traveled around this unit circle is exactly 2 pi units. Okay, if this is 1 meter, then it's 2 pi meters. If this is 1 mile, it's 2 pi miles. If it's 1 centimeter, and 2 pi centimeters. Okay, and the reason this is useful is because all circles are similar. So all circles are similar. So if I know that the unit circle with one unit has a complete turn or complete revolution is 2 pi radians, then I can figure out how many any circle might be by just taking those same 2 pi radians, right, and multiplying by the radius of my new circle, because all circles are similar. So the proportionality will remain the same. The trip around the circle is going to stay proportional to the radius. So all I have to do is think, okay, if I've got a radius of 5, then I would say, oh, all the way around is 10 pi, right? Now we get to the point of saying, well, what about partial rotations? Not 360 degree turns, but a partial rotation. Well, a partial rotation, we'd measure it in some x degrees, right? So let's just think about it. If it was d degrees out of 360 degrees, we know that it's going to be equal to r radians out of 2 pi radians. So now we can use this to solve for this is an equivalent ratio. D degrees over 360 degrees is equal to r over 2 pi. R radians over 2 pi. So let's say I know the degrees and I want to solve for radians. Well, what I would do is I would just do basic algebra. D over 360 equals r over 2 pi. I would multiply both sides by 2 pi. And I know that d over 360, all right, that's a d, times 2 pi will give me how many radians that is. I just enter my degrees. So this right here is very important. This is my formula for converting degrees to radians. Okay? I can take this same thing and let's find the formula for converting radians to degrees. Well, if I wanted to do that, I could take d over 360 is equal to r radians over 2 pi radians, and I would just multiply both sides by 360, and I would cancel, and I would say the number of degrees that we're talking about is equal to r over 2 pi, so I'd enter however many radians it is, divided by 2 pi times 360. So there's my formula. That's my formula for converting radians to degrees. Now we'll take a simple one. I know that pi over 2 is 90 degrees. So pi over 2 radians, I can plug that in, pi over 2 divided by 2 pi. So pi over 2 divided by 2 pi times 360. How does that turn into 90? Well, because, we believe that it's 90 degrees. So we put a little question mark. Is that 90 degrees? Well, remember how we divide fractions. These are compound fractions. We don't like that. So pi over 2 divided by 2 pi. That's how that goes, right? Times 360. Well, what do? We inverse and multiply. So we end up with pi over 2 times 1 over 2 pi. The pi's will cancel, and we end up with 1 over 4, and this is, of course, times 360. So 1/4 times 360 equals 90. So that's where we get our degrees from, and that's how you can do this, okay? That's your degrees, which is equal to 90. Yes, just what we thought. Okay, so it's important you know this. This is our review. This is our our recap. Remember these formulas. Okay, you're going to need to use them from time to time. Remember when they talk about radians, all they're talking about is a way of measuring an angle, right? And that a radian is a measurement around this unit circle. And the beneficial part of radians is that because all circles are similar, if we take our angle degree of the central angle, whatever it is, if we take that's measurement in radians, then we just multiply by the radius and we'll have the length of the arc. So that's the benefit there. One last example. Let's say I had a person that said, hey, let's lay out an arc that'll cover a 60-degree angle. Okay, and the radius is, let's say, 15 meters. And so we want to cover all of that. Well, what I would do is I would use this formula. So I'd put 60 over 360 times 2 pi to convert that into radians. That'll tell me how many radians this is. And then I'm just going to multiply it by 15 to figure out how many that works out to. So 60 divided by 360, that's also, the zeros will cancel, and this is 1/6. 1/6 times 2 pi. And here this will turn into 3, and that turns into 1. So we get pi over 3 radians. Okay. And so that's how many radians I have in that rope or whatever, the garden hose or whatever we're going to lay out here. It's going to be pi over 3 radians, but we have to scale it out for a 15-meter circle, so we go pi over 3 times 15. Now we're actually doing meters, so this would cancel and this would cancel. Get 1, and that turns into 5, so our answer is 5 pi meters. That's how long it is. Okay? An arc of 60 degrees on a circle of 15 meters has a length of 5 pi meters. And now you see how that's done.